And this is the 3.3 tutorial. It's solving equations with variables on both sides. Again, we're doing things you know how to do. We're just kind of adding steps each time so that we are now pretty much at the point where we're solving really big equations with multiple steps. But again, you know each step. It's just a matter of putting them in the right order and doing the right thing at the proper time. So let's look at this. We have never had, as this first equation has, a variable on both sides. But again, and again, let me get something to write with here. Um, what I want to do is solve it just as if I would solve any equation. Okay, I do this line, you don't have to. But I want to have the variable on one side. I want to have x equals something, okay? And I can't have x equals something unless the variable is on one side of the equation. And so since I'm um, always try to have the variable on the left-hand side, that's the way I was taught in high school. Always make sure I want to try to cancel the variable out on the right-hand side, okay, so that the variable's on the left. Now, you don't have to do that. The point is to cancel the variable out on one side or the other so that the variable is only on one side. So here, I'm just going to cancel this variable out. It's positive, so to make it cancel, I've got to subtract it. So if I subtract 3x, not 3, I have to subtract 3x, okay? I can't subtract 3 from 3x because they're not like terms, but I can subtract 3x from 3x. That makes it 0. But if I do it here, I have to do it over here. Like terms, okay? Again, like terms. Okay, that cancels that. Now I've got 6 over here. I've got 2x minus 2 over here. I'm down to a two-step equation. You know how to do this. Get rid of the negative 2 first. I get 2x equals 8. Then the last thing I do is get rid of that multiplication bond by division. I get x equals 4. And there we have it. Look at the next one. Again, I want to cancel the variable out on the one side or the other, and I would suggest you do the same thing every time, unless you're really good with this and you don't have any issues with it. I want you just getting a pattern and doing the same thing every time. I'm just going to cancel it out on the right hand side every time. Now, doing it the other way is fine, but I'm just going to do it here. Okay, so I'm going to subtract 11y because I want it to go away here. But I have to do it to this side also. And again, I'm doing like terms. That cancels that, which is what I wanted. I get negative 17 here. 8y and a negative 11y give me negative 3y. I've got plus 4. Now that equals negative 17. Two-step equation. We know how to do this. Subtract 4. We get negative 3y equals, and that's going to be negative 21. Last step, get rid of this multiplication bond by division. Negative 3, negative 3, that's y is equal to, this makes a positive 7. Again, one step, and I got it to a two-step equation. And it's something you know how to do. Again, I'm going to cancel the variable out on the right-hand side. Here, now again, you don't have to do this. I could cancel it out here. I could subtract x from both sides. I'm just doing the same thing every time because it helps some people to do that. Okay, subtract 9x from here, subtract 9x from here. That goes away. Cancels. It's 0. That's equal to, okay, positive x, that's a positive 1x, remember. Not that I always write it, but positive 1, negative 9, that gives me a negative 8x minus 1. Okay, two-step equation, add 1 to each side. I get negative 8x equals 16. Last step, get rid of the negative 8 by division. Make sure it's negative 8 on both sides. I get x equals negative 2. And I'm finished with that equation. Again, we just added an extra step to what we were doing. Okay, here, more of these equations. We probably won't do all of these, but let's just do a few of these. Again, draw the line down. That's kind of a crooked line. Let's see if I can do a better job with that. No, I didn't want to do that. Okay, where are we at? Here we are. Okay, let's just keep it. I want to subtract 9x from both sides. Okay, when I subtract 9x from both sides, 13 minus 9 is 4, so that is 4x minus 22. And that's going to equal, what do we have left over here? Negative 6, okay? Two-step equation. We know how to do this. Add 22 to both sides. We get 4x equals, well, 22 and a negative 6. That's going to be a positive 16. Last step, divide by 4. Divide by 4. X is equal to 4. There we go. Let's look at this one. I've got 14x here, got a 19x over here. Let's get rid of one of the x's. So I'm going to subtract 14x from both sides because I want it to cancel. I do that, that goes away. What am I left with? I'm left with a two-step equation. This is 5x plus 26 equals 41. This is pretty easy to handle. Subtract 26. Subtract 26, I've got 5x equal to, that is 15. Okay, divide by 5. Divide by 5. I get x equals 3. Cleans up rather nicely, I think. Okay, here, let's go ahead and do this one. Okay, I've got a negative 4x on one side, a negative 7x on the other. I want to get rid of the x on one side. So I'm going to add 7x to make this cancel. Add 7x to both sides. That goes away. 42 is here. I've got 15, and this gives me a positive 3x. Okay, get rid of the 15 and the 3. I want to do the 15 first. I don't want to divide. Almost did that. Subtract 15 from both sides. I get 3x equal to, well, that is going to be, let's see, 27. Okay, 42 minus 15, 27. Divide by 3. Divide by 3. X equals 9. And we're good. Let's look at the next page. We've got a few special equations we want to look at. Now, these are going to be different for you. They're not hard to solve. You just need to remember what the answer is when you get to this point. Okay, so this one has parentheses, and we want to take care of that before we cancel any of the x's out. So let's take care of the parentheses first. Always do parentheses first. That's 10x plus 5 equals 10x. Okay, well, I should already see I have a problem here because 10x plus 5 shouldn't equal 10x. Well, let's go ahead and cancel the variable out on both sides like we would do with any other equation. Subtract 10x from both sides. Okay, well, what happens? That equals what? 0. That equals 0. What do I have left over here? Okay, I've got something like 5 equals 0, which doesn't make sense. This can never happen. Okay, so when we have an equation like this, where we get down to here and this is not true, we know 5 does not equal 0, we would say this equation has no solution. There's not a single number that would make this equation true. Okay, so this is one you'll see probably a couple of times in your homework. It has no solution. Now I could look here in this step right here and tell it had no solution. But just to show you, go an extra step. 5 definitely does not equal 0. So we have one that has no solution. Okay, those are easy equations. Look at this one. Okay, this one has parentheses and variables on both sides. Again, parentheses first, deal with that. So the next step would be 6x plus 2 equals, and we want to multiply that 6x and then plus 2. Okay, I can already see this is a little different because I have the same thing on each side, but let's go ahead and just take it down. Okay, let's cancel the variable out on both sides. Okay, that goes away, that goes away. What am I left with? 2 equals 2. Well, this is different from the other one because this one is true. I lost the variable. I've got 2 equals 2. Anytime you have this and this the same, this is an equation that has all numbers. I'm using your hashtag, I'll call it a number sign, all numbers as a solution. You would say all numbers are a solution, or just all numbers would be fine. All numbers. Okay, that means any number I put in for x is going to make this true. I can choose 0, I can choose 1, I can choose negative 500 million. I put it in there, I get the same thing on both sides. It's a true statement. So when you get something like this that's true, it's all numbers for the solution. When you get something over here that's false, it has no solution. Okay, let's look at one more thing, or two more things. Find the perimeter of a square. Well, one thing we know about a square is that the sides, all the sides are equal, okay? So if we have this side and this side, whoops, didn't mean to mark on that. Those two sides we know are equal. We don't know what x is. And to find x, you have to have an equation. I have to have something over here, something equals something, to figure out what x is. Well, I know with a square, it may not look like a square, but it is a square. Okay, I know with a square that both sides are equal. So can I make an equation from these two? Yes. Because I know that 2x should equal x plus 4. Even though they're different forms, what we're saying is their expressions are, they're equal expressions, okay? And we've done this before. They're different forms, but they are equal because this is a square. So x plus 4 has to equal 2x. Now I just solve. I can subtract x from both sides. This is very easy. I get x equals 4, and we are done with finding x. Now I just need to find the side length. Okay? If x is 4, then 2 times x is the same as 2 times 4, and this is what? 8. And just to check our answer, 4 plus 4 is 8. So all of the side lengths are 8. So how do we find the perimeter? Well, it's just 8 times 4. What is 8 times 4? 32, and that would be 32 units. And that's finding perimeter. Okay? Let's do one more thing. Always want to throw a word problem in. This is a different word problem because we're probably going to have a variable on both sides. But it's still similar to the ones we've been doing, just with a little bit of a twist. So let's look at that twist. The Spanish Club is arranging a trip to a Mexican restaurant in a nearby city. Those who go must share the cost, the $60 cost of using a school bus for the trip. The restaurant's buffet costs $5 per person. What does that sound like? Sounds like a rate. How many students must sign up for the trip in order to limit the cost to $10 per student? Okay, this is a rate too. We've got two rates. Okay, now what's the question? How many students must sign up? So your variable is equal to what they're asking for. X equals how many students? Okay, X is how many students. Well, the rate here tells you what to multiply by. $10 is going to be multiplied by students. That's X. This rate tells you what to multiply by. $5 per person. That's X. Okay? So we're going to have an equation. What they're saying is, when is this up here equal to $10 per student? Well, $10 per student is 10X. Now this other, I have a one-time fee of $60, and then the buffet is $5 per person, or 5X. So they're saying, when is this, how many students must go so that this is equal to this? And that's all they're asking. Again, the rates are multiplied to something. I've got a rate here and a rate here, and then a one-time cost here. Okay, let's solve this. Here it'd be easier just to subtract 5x from both sides, because this will save a step. Okay, this is 60 equals 5x. Last step is to divide by 5, and we get x equals 12. So 12 students would be the answer. Okay? Basically, we still have rates, we still had a fee, but one side, basically, we had a variable on both sides. And this is one of these word problems you see that actually has a variable on both sides. But this was a total. They said, how many students must sign up so that the total is this? It just happened to have a variable in the total. Okay? So it's really not a lot different than what we've been doing. And that concludes the tutorial for this section.